All right, this release of PSCAD, which is going to be the first release of the 4.6, it's going to be the 4.6 minor update, the first release of that. It's the culmination of almost 3 years of development. We've put a lot of work into this version of PSCAD. There's a lot of great GUI features that we've added in, and we're really excited about getting it out to everybody. And I'm just going to. There's a lot of stuff to talk about, so I'm just going to go over the just the highlights of the features and stuff that we have in there, just the more important ones. This is the most significant minor update that we've done in years, probably in terms of the volume of new stuff that's going into it, probably the biggest one ever. So, like I said, we are really excited about getting it out. There's about 25 new features, possibly more. That's just an approximate. There's about 15 new master library models in this version, and there's about 15 or so deficiency fixes. And deficiency fixes are they're enhancements or alterations to existing features that are already in there, and that's usually based on user feedback. People will say, well, you know, it'd be nice if it worked a little bit more like this, and so we try to change that around and keep as many people happy as possible. The last I checked, we're at about 140 bug fixes now since version the release that's currently out, version 4.5.3. So as you can imagine, it's quite a significant release. So just to highlight some of the new features before I go into a little bit more detail. The biggest new thing that we're offering in this release is the electric network interface, and this allows you to piece together electric networks by subsystem in different projects, in separate projects in PSCAD, and then link them together into one single simulation. What it does help to do it is especially helpful in when you have large cases that have fax devices and fast switching, other types of fast switching devices that are interconnected by transmission lines. We can break this up into several different cases, and you can even actually run two different separate applications of PSCAD on two different machines and connect them together that way. So we're really excited about this, and I'll demo and talk a little bit more in detail about that in a bit. We're also going to be introducing with 4.6 a new type of licensing that we're calling certificate licensing. It operates over the internet, or it's cloud-based. Your PSCAD will download a certificate from the centralized license manager, and your account and your licensing details is all in the cloud as well. You can log on to your account through a web portal that we have called My Center. My Center's been around for a while now. Many of you probably have used it. So yeah, so there's that. And the next is we are introducing a graphical layers feature, where this basically enables you to enable disable components on the page or make them invisible. It really gives you a lot of flexibility when using PSCAD. You no longer have to maintain several cases. If you have minor changes in between, you can just enable and disable based on layer. We're introducing a parameter grid pane, and what this does is you can select any component in your project, and it will give you a table view list of all of the parameters for that particular component in a nice table view like this, including navigational links, and it's all, you can edit all the parameter values from here. You can edit multiple ones simultaneously, and you can even save. You can even save to CSV file format, to load up into Excel and things like that. We also have a comparator tool, which is a graphical tool that's used to compare two module schematics. What it does is it'll tell you the differences in terms of parameter values and if you've moved a component or anything like that. This is usually helpful when you have page modules that are unique, but they're very similar, and this will help you to find all the differences in between them. And we also have a copy transfer feature, which is an extension to the copy with dependence, and I'll get into more detail about that in a bit. New master library models. I said there was about 15 in total. These are the more important ones. We're introducing a frequency-dependent network equivalent, or FD&E, which basically you can use the frequency scanner in PSCAD to generate an impedance spectrum of your network, and then you can use that as an input file to the frequency-dependent network equivalent component and just reduce your network right down to what you need, just a few buses or a few nodes to do your study. There's also a frequency-dependent transfer function. This allows you to, through state variable input, to model the response of any system with using control signals. The battery model that we've been passing out to people for a long time is now finalized, and it's part of the master library. And also the same thing with the statistical breaker. We have been giving that out for a while as well. That's now part of the master library. And we've also included a hysteresis model in all of the classical transformers. So there's two model types for that. There's a simple one, and there's a Giles-Atherton as well. So I'll talk about that a little bit more coming up. Another thing that you should be aware of when using 4.6 is there's always problems when we continue on and develop the software and move forward. Sometimes there are things in the previous versions that were, I guess you could call them loopholes, whatever. We usually will find that they'll end up causing a problem, and so we have to slightly modify the way we do things, and this can cause some problems when people are upgrading, because then they have to go and manually update their projects so that it'll work in the newest version. What we've done is we've created this section in the application options called legacy import and load, and when we can, we've provided automated features here to help you to bring your case up to speed with as minimum work as possible. So we've got about 5 of these in there right now, and I would suggest that when you do get version 4.6 and you load your projects in, you could try loading them with all of these disabled at first and see what happens. And if you run into some problems, you can go back, unload the project, go back and turn them on, and then reload the project again, and it will repair it for you. I'll just talk about a couple of these, or a few of these in detail. One of them is the version 2 and version 3 users. I know there's probably a couple of you out there. You'll remember the DataTap 2 component. This is one of those things that we had decided that we just can't keep it in. So it was causing a little bit of problems with the compilation of projects and things like that. So what we have is there's an automated feature here to convert DataTap 2 components to their equivalent DataTap and data label. So that will be all automated for you when you load the project. Define directives, another legacy version 2, version 3 script directive. They're not used anymore. They're obsolete. So if you turn this replacement one on, it will replace everything, all define statements with local directives, and for subroutines and functions and variable declarations and things like that. Orphan global substitution removal. This one is a little bit more complicated, but the way we had implemented global substitutions in the original version 4.3, the original X4 version, is there's a slight issue with once the globals were defined, and they're defined as parameters on the main page. If you were to instantiate the main page, or was to copy that definition or something, and then delete the global substitutions, there would be instance values that would be left over or orphaned, and they would sometimes cause weird warnings when you're compiling the case. So this algorithm, what it does is it goes and finds these orphaned global substitutions, and it just removes them out of the case so that it doesn't cause any more problems. Now this is probably the most important one, and this the other three were added. You could find those in version 4.5 actually, but this is the one that we added for 4.6, and this is something that's very important, because I guarantee that most of you will probably have projects that involve this. Due to basically nuances in the Fortran compilers, we've discovered that there can be certain situations, and they're relatively rare, but there are certain situations where improper values can occur, and this is all due to the Fortran compiler. But basically, what we're saying is that you can no longer export name a local signal, and in this particular case, you can see this one's called out label. You can no longer name a local signal and then pass it directly out as that same signal name through an export tag. I know probably everybody does this, but it can't be done anymore, and it's just because of the fact that the export tag is declares it as an argument in the Fortran subroutine, and the other one declares it as a local variable, and there's a little bit of a compiler issue there. So this algorithm here will go and repair that for you, and if you need some more details on that, let us know, and we'll give them to you. Now, also with 4.6, we have done a lot of work optimizing the day-to-day, or the regular load and unload and save processes that we have in there. The original release of PSCAD X4 4.3, which was about 4.5 years ago, it was considerably slower to load and unload and save than version 4.2.1 was, the currently released version. I know a lot of you will probably remember that. Well, we've done a lot of work on that, and we've now increased the load speed in X4 to be approximately 2 megabytes per second. And we tested that 4.2.1 on the same machine and found that it was about 1.7 megabytes per second. So the X4 load process is actually faster than 4.2.1 now. However, your projects with the new XML format will of course be larger than the old 4.2.1 format. So the cases will probably still be a little bit slower, but the load speed itself, like the load of the cases, will be a little bit slower, just simply because they're bigger. But the load speed itself is a lot faster. Also, the message table, we have provided a lot of optimization for speed in there. So you'll see that that everything in PSCAD seems to be a lot quicker. The project canvas layout, that's the painting of the schematic, has been optimized as well, so that when you load projects in now, you won't see a delay in it drawing the schematic so much anymore. It'll be much more crisp and fast. So I've been using it a little bit recently, and I it is really nice. Actually, it's nice and crisp. Crisp is a great word for it. All right. Well, I guess that's enough talking, and for now, I'm going to start going and doing some demos in actually in PSCAD. But before I do that, what I want to do is I want to go back and talk about. Some of you may be familiar with simulation sets. They were released with 4.5, but I need to just quickly review those in order to before I start talking about the electric network interface and things like that. So back in the mid 2000s or so, the physical limitations of semiconductor chips, they started hitting the limit of that for clock speed. So manufacturers began to focus more on parallel computing and adding more cores to processors. You know, by about 5 or 6 years ago, our customers, PSCAD, started requesting that we start making use of parallel, multiple cores and parallel processing in PSCAD. Up to that point, PSCAD had not made use of parallel computing at all. There was usually, we would use 2 cores, one for PSCAD and then EMTDC would be launched on the other core. So we began to move our development direction towards parallel processing and multiple core processors. Version 4.5, we introduced two new parallel processing features. One was a parallel solution for the transmission lines and cables, and the other one was referred to as simulation sets, and I'll talk about those in a second. So the way we used to do transmission lines in the older versions of PSCAD previous to 4.5 were that we did them sequentially using one processor core. So as you can see here, we have, you know, an 8-core processor, and where we used to only use just 2 cores, one for the transmission line, one for PSCAD. So that was a little bit inefficient. So what we've done in 4.5 is we introduced this new concept now. So what PSCAD will do is it will detect how many cores locally you have on your machine, and then it will bundle the transmission lines into sets, and in this case sets of 7, because there's 7 cores available, and we'll launch them in parallel in sets of 7 until they're all finished. So if you have, you know, a 16-core processor or something like that, you'll see that it will actually launch 16 at a time. I don't know, I can't remember if there's a limit or not, but so. And then the second feature that we released was simulation sets, and I'm sure you've seen them. If you've been using 4.5, you've seen them there. They're an inherent part of the workspace. And as you can see in the image here, I've got a workspace here set up with 3 projects loaded, and there's a couple of simulation sets that as you can see there that we've set up. The concept of a simulation set provides the foundation for parallel computing in PSCAD. It's a kind of a container that we use to compartmentalize a particular launch of multiple projects. So then you can take any project that's loaded in the workspace, you can take it and add it as a task in the simulation set, and any task inside that simulation set will be launched in parallel when you launch the set itself. So I'm going to switch over now to PSCAD. There we are. All right. So here I have a workspace called simulation sets, and I have a couple of a few example projects in here, and a couple of simulation sets set up already. You'll see in the simultaneous set here that I've added a few tasks. Adding a task is easy. You just simply need to right-click on the simulation set and select Include Project, and you'll see a list of projects, so you can add them in that way. You can also run the set from here, remove the set if you like. There's some simulation set options. In this particular case, it's just the name, so you can make changes to the name and things like that. So each simulation task inside also has options as well, and you can just right-click on it, and you'll see that there's a simulation options there. You can bring up the dialog, and we'll talk about what these parameters in this dialog mean in a second. So now, these particular examples illustrate another feature that was introduced in an early version of PSCAD called the root control interface. And what it basically does is it allows for one root or master project to control multiple slave projects. And it uses the simulation sets to accomplish this. Like the simulation sets, the root control interface is an inherent part of the workspace, and it enables inter-project communication within a single simulation set. This is accomplished using the already well-defined radio link transmitter and receiver components, which were extended in version 4.5 to include a provision field for a foreign namespace, meaning a project that another project other than the one that you're actually transmitting or receiving in. This instructs the link to collect its value from a foreign source and thus allows for a more sophisticated means of multiple run control. So what this particular case here does is chopper optimization. This is the master case. What it does is it when you launch this set, or have it all part of a set here, there's the master case and three slaves. When I launch this, what will happen is that it will transmit data to all of the slaves. The slaves will run, and it will transmit their data back to the master. And you can see the receivers here collecting the data from the slaves. So what this enables us to do is, in this particular case, we're launching three parallel tasks to calculate data that we need for the next optimum run. So to run this root control example, I just simply need to run the set. And in between runs, the master and the slave will communicate with each other, and then launch again. And as you can see, we've added another feature to the transmit or to the radio link components here, where we can actually look at. This is the trend here over each run. We can look at how we're starting to get closer and closer to the value that we're looking for. Okay, I'm going to stop that. That is one way of doing the root control. The next example here that I have involves a new concept that we've added to PSCAD 4.6. Which is called single program multiple data, or SPIMD, what we like to call a volley launch. And essentially it allows you to launch multiple EMTDC simulations from a single project. So I have the other simulation set, which involves chopper optimization 2 and a single slave. The slave here is set to launch three EMTDCs from this one project. So I'll talk about how that's done here. Now you can see there's a little bit of a difference between this optimization case and the other. The big difference is the fact that in the other cases we had, we'll go to the slave, one of the slaves here. You can see that we have inputs set up in the slave cases because it's getting only the four values from the master. In this new case, we've moved, in this volley case, we've moved all of these to the master case, and then we've told it to send these particular values to that particular instance of EMTDC, and we call that the rank, or the rank number. So I'll launch this project here, and what it will do is it will launch 3 EMTDCs from that one particular case, and do basically the same thing as it did before. And as you can see, the results are coming back. Now, I know I'm glossing over this very quickly, and I have to, because I'll just run out of time if I don't. But if you need to ask questions or anything like that, we actually are going to have a panel here on standby, and they're going to be here to answer your questions, and we'll hang around for half an hour to even an hour after the webinar is over to answer your questions. You can ask the questions through the questions panel on your GoToMeeting. You should see that up there. So once I'm done talking, we can open it up for some questions, and we'll try to answer some of that stuff. Okay, so now that we have all that, we talked about the root control interface and the simulation sets. Now we can move on to the electric network feature. What I'm going to do is I'm going to open up that particular workspace here. I got a couple of examples in there to show you. All right. Okay. All right, the electric network interface. Beginning in version 4.6, multiple projects can be combined to form a larger electric network. A single electric network may be split so that each electric subsystem is represented by a separate project and thereby run using a separate EMTDC process. Each EMTDC process is linked together via the electric network interface to form a cohesive simulation that is run from within a single workspace. This enables a single simulation to execute on parallel processors. In terms of runtime information for plotting and online data, PSCAD and EMTDC communicate normally as they would for a single process. There is additional communication between the multiple EMTDC processes, however, due to the fact that each EMTDC process is an executable file. Each can be launched on its own processor core, enabling parallel simulation of the complete system. For larger networks containing multiple subsystems, using this interface can greatly enhance the total simulation speed, especially when the subsystems contain high-speed switching devices like fax. Okay, so setting up the interface, the boundaries of the electrical subsystems in EMTDC are defined via distributed parameter transmission lines and cables. And so it makes sense that the transmission segments themselves be the linking points in a multi-project simulation. As a very simple example, let us take the slightly modified version of the Seagray benchmark model, which I have here. And all we've basically done is we've just added a transmission line in between the two converters where there was just a passive network before. And it's just just for a simple example to show how to do this. So here's the original case, the slightly modified original case. So what we did was we have to manually deconstruct this case and create two separate ones before we can use the ENI. So the addition of this line to the system results in a division of the electric network into two separate subsystems, in this case approximately 25 nodes each, and these two subnetworks can be compiled and launched as separate but dependent processes. Due to the natural propagation of delay generated by the distributed transmission line. So before this can be accomplished, however, the project must be manually split. Like I said, splitting the project up can be achieved in a number of ways, but the most efficient way to do it is to duplicate the project and then manually modify each one. So we've done that for demonstration here. So we've taken this project and we've split it into two. So here's the rectifier side, and you'll see that it has one side of the transmission line and the transmission line configuration here, and then the other side is the inverter. In order to run these, like I said, we had to put both projects inside of the simulation sets. Simulation set. So I'll launch it in a second. So the transmission line and cable parameters, a few parameters and functionalities had to be added to the overhead line and cable configuration, as well as the interface components, in order to accommodate this feature. So there's one thing that we've done is we've added a couple of new termination styles for the transmission line. So if you go into the parameters and have a look, previous versions, you will remember the local connection and remote ends. Those are pretty familiar. But we've also added in foreign ends and alien ends. So these two are used specifically for the E&I interface. Selecting foreign ends means that you're going to be running these two projects within the same workspace. So both projects have to exist in this particular, and this is what we're doing here. They're set up as foreign ends. You can, if you want to, run this simulation across two separate computers or two separate instances of PSCAD. You would select alien ends and set it up that way. I'm not going to talk about the alien end stuff this time. If you're interested in learning more about that, let us know. So also we've added a there was also, let me see, yes, I think there's something in the, oops, I think there's a new parameter in here as well. Yeah, no, yeah, we just did that. So also in the interface components, we've added this section here called non-electrical signal transfer. Now, this is for control of a new concept we had to add in that we in order to accommodate E&I, that we call the control signal carrier. And when a project is decomposed into separate electrical systems, there will be situations where control signals generated in one project are needed in another. So the E&I utilizes a concept referred to as control signal carrier, which allows control signals to be piped through the transmission line interface along with the electrical data. The control signal data arrives at the other end with no time delay or travel delay. In the example given here, the current order control signal is generated in the inverter case project and then passed via control signal carrier to the rectifier in the other project. All right, so I'll just demonstrate this here. To run an E&I example such as this, you just set it up in the simulations and just simply run the set. Now, if you could look at the core usage on my machine, you would have noticed that I have a 4-core machine here. So you'll notice that two of the cores would have launched and run the two cases simultaneously, and they communicate through TCP sockets. As a better example, we have this large case here that has two generators attached to it. So what we did is I launched this, and I was looking at it actually yesterday, and when I launched and ran this, I believe it took about 24 seconds to run on its own. So what we did was we took this and we converted it into an E&I case where we took those two generators that you saw down at the bottom and we connected them via transmission lines to the to these two separate cases here, generator 1 and generator 2 on the other side. So what this is going to do is it's going to take those two generator subsystems, and it's going to launch them simultaneously. So what ends up happening is I don't really have time to show it to you here, but it actually did speed up the simulation by, it almost cut the simulation time in half. It was about, I'd say, 60% of the original simulation time. So just in this simple case, there was quite a lot of it was quite beneficial. All right, that's the E&I feature, and I'm just going to flip back to quickly here to my PowerPoint presentation. Now, the next thing I'm going to talk about really quickly here is the centralized license manager. The first versions of PSCAD were licensed by binding it to the target machine hardware. version 2 users will remember that. Ever since the very first Windows platform, this method was no longer feasible, and so a new system was put into place, and using the hardware lock and license manager and all that stuff. There's a little bit of rigidity to this system, and so this led us to this next generation of licensing, and what it does is it uses the cloud system to provide certificates to your machine. It's actually very easy to use. You simply set up your account with MyCenter. We have control over how many licenses you have, just like we do with the dongles and license manager. And all you need to do is just simply log on, get your certificate on your local PSCAD, and then it's good for. I'm not really sure how long the time is at this point, but it's good for a couple of weeks or something like that, and then you can go off and you can head into the jungle or wherever you want to go, and you can do your PSCAD simulations, and you won't need a dongle or a license manager or anything. They'll just run. So I'm just going to go over that. I just went over that really quickly, but that's coming in the next version. So I'll flip back to PSCAD here. Okay. So the comparator tool, what it does is, I'm just going to quickly demonstrate that here. I'm going to use this new feature called copy transfer that I'll talk about in a little bit, and I'm just going to make a actually, no, I'm going to do the inverter here. I'm going to copy transfer that, and I'll do this a little bit slower next time. All right. So now I have two unique inverter instances on here, and what I'm going to do is just move some stuff around, and I'll change maybe a parameter in the transformer here. Okay, so now I have these two instances of the inverter, and I've made a slight modification to both. To use the comparator, you simply go up to the Tools button in the ribbon and click that, and you'll see the controls here for the comparator tool. So I'm going to go in, I'm going to select the module. They're both in the CGRI benchmark. One is the inverter, and the other one is the new one I created called inverter under 1. So I'll select that one, and now I just simply press the compare button up in the top left corner, and there we are. So the comparator tool shows you exactly what is different in the two projects, or in the two canvases. You hold the mouse over it, it'll tell you, see, I changed this parameter value from 591 to 581. So it'll tell you exactly what's different in the two projects. Okay, that's the comparator tool. Also, we've introduced the parameter grid pane. I'm just going to open up a new workspace here. Open workspace. All right. No, I don't. Nope. Okay. So this example case here it's part of the examples that come with PSCAD, and they basically it's just a bunch of fixed loads. So what I'm going to do is I'm just doing this because there's many instances of the fixed load here. So I'm going to open up my my parameter grid pane, and parameter grid's right there. If you want to load it up, you just any of these panes that I'm going to talk about, you just simply need to go to the View tab in the ribbon and select the panes drop list, and you'll see a list of all the different panes in there, parameter grid being one of them. So As you can see, it's empty. The pane is empty at this point. So what I need to do is just go over to the component that I want to look at and right-click on it and select View Parameter Grid. So I'll do that, and you'll see that the parameter grid pane will populate itself with all the parameters for the fixed load. So what's nice about this is every bit of parameters for all these fixed loads are here. So I simply need to it contains like a navigational link feature here, which is really nice. So I can navigate to every single instance of that component on the page if I like, just by clicking those links. Now I can also select any cell of any instance here, and I can modify parameters from there. Sorry about the delay. So I can do a single cell, I can do multiple rows of a single column. You just select them all, right-click and select Modify. And you'll get a dynamically generated parameter dialog that will come up. You can enter in the new values or select from a list of, it'll collect a list of possible values that are there, or you can enter them in. In this case, I'll just enter them in as something new, and I'll call them both 102 and put in the units and press OK. All right, so you can see that the parameters all change to 102. If you go to those particular components, you'll see that the parameter inside the component is also changed. So it's all dynamic. You can also do multiple rows and multiple columns at the same time. If I select them all and select Modify, I'll get all three columns. I can go in and change all the values simultaneously. It's a great little system for managing the parameter inputs for components in PSCAD for sure. And the final thing for the layers here is you can select any bunch of columns or rows and right-click and write them to a CSV file. So it'll generate a CSV file for you, and then you can load that into Excel or whatever. All right, I'm going to go back and I'm just going to load up that E&I workspace again. All right, the next feature is the bird's eye view navigation pane. Very simple feature that's really great. I use it myself a lot, and it was something that was in version 2, as a matter of fact, and we have brought it back now. So, as I said, go to the View tab and to the Panes view if you can't see it, and you'll see the tab down here. So this is the bird's eye view in the bottom left corner. You'll see that what I'm currently viewing is this blue box here. I can grab the blue box and I can move it anywhere on the page and release my mouse button, and it will navigate to that particular part of the page. I can zoom out by making the box bigger. So if I stretch it, that, and let release, I'll automatically zoom out. It also works, I can zoom in, make the box really small, release, and you'll see it zoom into that one area. So it's especially when you're working with large cases, it's a great navigational tool for that kind of thing. Okay, another cool little feature that we've added in there is added into PSCAD is the ability to drag and drop projects right into the workspace. So I'm not going to bring up Internet Explorer File Explorer or anything, but basically what you do is bring up File Explorer, and you can just select any workspace or project file and drag it directly into the workspace window, and it'll automatically load it for you. So it's a very convenient feature. Another convenient feature that we added in here too is the, and I use this all the time as well, I love it, is the show in folder. Basically what this does is you just select that and it opens up that file location and points right to the project. So it makes it very easy to find a particular project. Before, if you recall, you probably had to use like save as or whatever to figure out where the project was. So this is a little bit more convenient. It also works for workspaces as well. Okay, I'm going to just open up, I'm going to create a new workspace here, and I'm going to open up our multiple run example, and I'm just going to find the tutorial folder. There it is, and multi-run. Okay, so we've added two new buttons to help control simulations. I'm going to launch this one here. This is a multiple run. Now, if you were, showing this to a class, if you're a university professor or whatever, and you're showing this to a class, it's a little bit fast and kind of a pain. So instead of going in and reducing the time steps so that it'll run slower, what we've done is we've just added a slow button. This was actually requested several times by many people. So if I now select slow and launch the case again, you'll see that it runs much slower. Basically, it just adds in a time delay at each time step for you. You have a little bit of adjustment. I can slow it down really slow, or I can adjust. So you have a little bit of a window of adjustment there. The big thing though is don't forget to turn the slow button off, and I've done that many times, and I'm wondering why my simulations are running slow. But yeah, so just remember to turn it off when you're done using it. Okay, so now I can demonstrate, now that this is running slow, I can demonstrate the other feature that I wanted to do, and this is the multiple run skip. This can be convenient when you want to skip through a bunch of multiple runs that you don't want to see. You don't want to wait through the whole thing, so you just press the button and it will go on to the next multiple run. All right, I'm running out of time here, so what I'm going to do is I'll just go over this other stuff really quickly. We've added in, and we can discuss after 10 o'clock when the webinar is finished. We've also added in search history, wildcard characters in support file paths. So if you have additional source and object files and things like that, you can put in star.star or star.f so that it will include all Fortran files in a particular folder. The sticky dialog has been updated. I can show you that here. To type in, you just have to double click on the sticky note now and then add text, and click outside, and it will it'll add the text to it. The properties are just right click and select edit properties. Okay, workspace progress bars, you may have noticed those while I was running the case here. You'll see that it gives you a progress bar up here in the workspace, and also down in the taskbar down at the bottom. You'll also see that it's showing it there as well. We've added in some freehand selector tools. Do those really quick. So you can go in here, select the freehand selector, for instance, and you'll see it up there on your screen. I'm just going to stop that. So select freehand selector, and then I can go and I can draw. I can trace around with my mouse and select certain things. Nice little convenient feature. There's also a point-to-point selector as well too. A nice little feature that we've done here too is called consolidate. I don't know if you're used to using workspaces, and you want to transfer an entire workspace to somebody else. It can be a little bit inconvenient. So what we've done is we've added in a consolidation feature here. If I go to show in folder, You'll notice that the only thing inside of this folder is the simulation sets file, and that's because all of these other projects are stored separately on my hard drive. So if I want to consolidate this together in order to send it to somebody, all I simply need to do is select Consolidate, and the folder that I want to consolidate it to, which is this one, I select the folder and continue on, and you'll see that what it does is it puts all of the projects nicely organized into folders inside of this folder. So, and it also includes resource files like Fortran and object files as well for each project, and actually resets all of the file paths in your projects for you. So after you consolidate that workspace, all you simply need to do is go up to its parent and zip it and send it off to somebody, and there you go. They can unzip it on their machine, open it up, and everything will run. Okay, so that's it for the new GUI features. A couple of other deficiency things that I'm going to show you, and yes, I know I'm running out of time, so I'm going to go really quick. The transmission lines page, this is very nice, something that people have been asking for a while. All of the towers now for transmission lines and all of the options and everything are all in the ribbon bar now. So you don't have to go back and forth between the master library or use the cumbersome menus anymore. They're all right there. Hold your mouse over it. It'll show you exactly what you're plunking down on the page. So that's a great nifty little feature. All right, what's next? Okay, and finally, in terms of features, I'm going to just talk quickly about the copy transfer. You saw me do that with the, which one was it? Was it this one? Yeah. If you remember copy with dependence, I'm not sure if anybody's ever used that. It's what it does is it copies entire module hierarchies for transfer to another project. But you needed before to do it on the definitions branch, and what you then have to do is instantiate it and all that stuff. So what we did was we just kind of built onto that feature to make it a lot more convenient. This is a module hierarchy here. This is an inverter that has another page inside of it that houses the inverter controls. What all I have to do in order to make a unique new module hierarchy here is to just right-click on the component and select Copy Transfer. So I do that, click, and now I can just paste it onto this page, or I can go to another project or wherever, right-click and select Paste Transfer. I'm going to do that inside this project, so of course it's going to ask me to rename the definition file name, or the definition names, which does, and there it goes. It just plunks another instance, another unique module hierarchy down on the page. All right. Now the master library models, like I said, I have kind of run out of time here. So the main ones were the frequency dependent network equivalent. What we can do is, if any of you have any questions on that or how to use it, I explained it a little bit earlier, and I'll just kind of bring it up here really quick. I have an example case that demonstrates that. So here what we've done is we've taken the IEEE 39 bus case and we've reduced it down to I think 7 buses, and the rest of it is equivalenced inside the frequency dependent network equivalent. So if I run this case, what we have is the original case, the output files for the original case that we're plotting via the file component here. And as you can see, if I zoom into the transient here, what we're doing is we're switching in a line, I think. You'll see that the original and the equivalence one is quite close. Like, I mean, it's very close. It's of course an approximation, so it's not going to be exact. But this just shows how it does a full frequency dependent network equivalent of the line, and it does that using the same curve fitting algorithm that we use in the transmission lines. The FDTE component, this particular case here, we're modeling this passive network, this passive electrical network as a control system. The data is input as state variable input, and here's an example file where you have the A, B, C, D, and E matrix values. Yeah, like I said, if you want some more information on using this component, let us know and we'll answer all your questions. Okay, so that's the FD&E and FDTE. We've also added like I said, the hysteresis to the classical transformers, so you'll find that in the master library. We've added a pause and stop component. Components, so basically they work on a rising edge signal, so you can put them in as controls components on the page, and I believe they're in the miscellaneous, I think. No. Maybe they're down in here. Oh, that's funny. Oh, anyway, so they're just you just apply a data signal to them on a rising edge and at a certain time, like using a comparator or something like that, and it will either pause or stop the simulation at a certain time based on that control signal. We've also added the battery model. It's simply an ideal controlled voltage source in series with a resistance. Let's see, what else have we added? We have a multi-mass interface to the permanent magnet machine. Now that's something that we didn't have before. Also, there's data merge components that support array signals as well, and you can see those here. You can send in arrays and merge collections of arrays together into a larger array. Bit of a convenient feature. Also, the statistical breaker model. It's used in single pole operation for a three-phase breaker, and it will operate the poles in a statistically distributed manner. We've added a neutral connection to the synchronous machine, something that a lot of people had been asking for over the last little bit. We've increased the maximum number of cables from 8 to 12 in the transmission lines program. And we've also added a nifty little feature that I'll just show you really quick to the cables. And I know everybody that's used cables before finds this, if you wanted to externally connect the armor, the sheath, or the outer conductor, or whatever, to ground, you'd have to add a resistor in here. And it was got a little bit messy with all of the resistors and stuff. Well, you don't have to do that anymore. You simply can just say that, do you want to ground the sheath, armor, outer conductor through a resistor? And you can select yes, and then add in the resistance value. So you do that, it cleans up the interface really nice, and so all of those, the sheath and outer armor and all that stuff are connected externally. Okay. One other thing here. One thing that was asked for a lot was people wanted the output channels to assume the name of the signal that it was connected to, and so now you're able to do that. So all you simply do is just on this parameter in the output channel, just use signal name as title, just select yes, and what it will do is the next time you build the case, it will convert the name of that PGB to the signal to which it's attached. If the signal changes, the next time it's built, it'll change the name of the output channel. All right. Okay, so we've added a simplified underground cable component as well. Sorry about that. where you can enter in. It basically reduces a lot of the data entry that you need. Here we have, like, if your configuration is a trefoil or something like that, and all the cables are identical, then you only need to add in the data once. This will work for trefoil, flat, two cables. There's a lot of flexibility there. It certainly helps to get things going a lot quicker. Okay, so that's it for the new features and master library models. In the line constants program, we have done a couple of new things, and I'll just go over them really quickly here. We can now have multiple pipe cables are now supported within the same right-of-way. You can now have a pipe containing either a single coaxial cable or an empty pipe now as well. For the pipe model. And also we've done a considerable amount of work on the traditional functional form method that's used by the DC correction algorithm, and has been replaced with a new method which is a lot more robust and stable than before. All right, well, I hope you enjoyed sitting with me and listening to me talk about my favorite subject, PSCAD. We're going to be, a panel of people are going to be sticking around for a little bit while longer to answer any questions that you do have. Please ask, and we'll either answer by voice or via the questions and answer pane. Once again, thank you for joining us, and I hope you have a great day. Thank you very much.